Hello everyone, today we have another Kurzgesagt video. Why humanity will never leave the solar system. And yeah, it might be a bit difficult right now. We don't have like the proper tech, but it's not like absolutely impossible. Go back like 500 years, guns, internet, a fighter jet. You wouldn't really imagine that. It would be like magic to you because it's just so far out there. And your technology didn't allow it. So you just wrote it off or couldn't imagine it. It's kind of like that. But let's see how this goes.
The latest limited edition pin is here, now available on the Kurzgesagt shop. You will never leave the solar system.
I don't like that thought though. Space is cool. Like, yeah, it's massive, huge, but there's so much cool stuff. There's like planets that rain diamonds. That would be cool to see. All like those ring worlds. The planet with the rings around them. All the the planet with multiple suns. It's just like kind of sad to think about. You would like never be able to get to see it.
Nobody alive today will, and maybe no human ever. Locked in by an invisible barrier, impossible to overcome for carbon-based animals like us.
Time,
and
probably.
Not just us.
Because it takes forever. Space is big, so your travel time is ridiculous.
There may be millions of alien civilizations in the universe, none of them ever able to venture into deep space in a meaningful way. Okay, but how can this be? We've made countless videos imagining how the exploration of the galaxy and beyond should just be a question of time, sort of mandatory for civilizations at a certain point.
Yeah, it feels natural. I don't know the word for it. Civilized? No. I guess I'll just say, mm, you basically, I don't remember the name for it. I don't remember the word for it. But you basically fully develop your world. You have nothing left in the world. And then you look to the stars. It just seems like the natural consequence, like the natural progression. But hearing that the stars aren't really like, obtainable. Like there's like end of the rainbow kind of, pot of gold. Technically there, but you can't really reach it. That's such a sad thought.
But there's a catch. We're pushing up against fundamental physics. What is this barrier made of dust and nothingness? And why is it so hard to overcome? You don't understand how large space is.
Yeah, it's massive.
We don't either.
Yeah. It's massive. Like you physically can't wrap your head around it. A human can say, yeah, a mile, 10 miles around the world, and not really grasp the scale of around the world. Like that's far. Even if you can cross it in like 12 hours, it's still far. But space, Earth is just in space, in its solar system. And space just continues on for what's basically forever, relative to like humans.
Conceptualizing the size of space is impossible for our ape brains that evolved to understand distances like right here and over the next hill. Space is so absurdly huge that we just check out and just hear very far and a million times very far.
Yeah, and that's something you can't really do on Earth. Like, I don't really think there's anything you can name that's like, yeah, it's this far away, it's 10,000 times this far away, and then it's a million times that far away. But space, you can do that. You can sit there and say, yeah, confidently, that right there is a million times away. It's a billion times away.
Feels the same, but it's not.
Yeah, it's not.
To help our brains, let's start with what makes us cross distances: speed.
Yeah.
The fastest a human ever traveled in space were astronauts at 40,000 kilometers an hour, returning.
40,000 kilometers an hour. I don't do KMH. I don't know the measurements. 20 24,854. So they were going almost 25. Yeah, they were going almost 25,000 miles an hour. That's ridiculously fast. Doesn't traveling at like those speeds have like adverse effects on your body though? Like I can't imagine that's like great for you.
From the moon in 1969. Not bad, but way too slow.
And that's the thing. Space is so big. 25,000 miles an hour doesn't really mean much.
The fastest thing humans have ever built by far is the Parker Solar Probe, which at this moment uses a physics cheat code hurling around the gravity well of Venus, accelerating to get closer to the Sun. After 7 years of doing this, the probe is shooting through space at a breathtaking 635,000 kilometers an hour.
That's insane. So basically, because there's not really anything to slow it down in space, they can just keep slingshotting it around Mars and the Sun to increase the speed. But it's still how much is 635,000? I don't know why it's KMH. 635,000 635 K KM to MPH. Nope, 635. I'm slow. 635. 300 thousand 394,578 miles per hour. Okay, yeah, no, that's fast. Really fast. But it still took like 7 years of looping around Mars. Well, what was it? What was it?
Well of Venus,
Venus and the Sun to do this.
accelerating to get closer to the Sun. After 7 years of doing this, the probe is shooting through space.
But the way it can just like continuously build speed like that is crazy. If you leave it for like maybe another 5-10 years, wouldn't it like keep just rising?
At a breathtaking 635,000 kilometers an hour.
That's fast.
Fast enough to go around the world in 4 minutes, or to cover the distance from Earth to the Moon in 36.
Can you wrap your head around going around the entire world in 4 minutes? Like that's like you starting from your house, going straight up, and then just going straight forward around the world. And then you'll be back at your house in 4 minutes. Like that's insane. And then to the moon, like the moon is far. It's like it looks close in almost every depiction of space, and it technically is close relative to like space. But the moon is
So
far.
let's pretend we had a spaceship that fast with a human crew ready to explore the universe.
That's the thing though, with humans. When you have things like this, where you're sending people, it's kind of hard to do because once they take off and go, they're not getting any of the upgrades or advancements that Earth might be having. So say the trip takes 50 years. They would have gotten there in 50 years, but then if they waited 20 years, maybe the journey would have taken like 5 or 2 or 1 because of advancements. Yet they spent their entire lives on that trip because just of the time they chose. You send someone 30 years, and then you send someone 30 years later and they catch up to them in 2 years. It's just depressing for the people that went 30 years ago because what was the point?
Current rockets would need 7 to 10 months to reach Mars, but
No, Mars is really far. But it's space. Everything is really far.
our new spaceship covers the distance in just 2 weeks. Pretty good.
Ooh,
But our
7 to 10 months to 2
new
weeks.
spaceship
It's a 7 to 10 months because Mars moves.
covers the distance in
Earth
just
moves
2
too.
weeks. Pretty good. The next stop is Pluto, which we'll reach after about a year.
I think AUs are the distance from Earth to the sun. So Pluto is what, 40 times further away from the sun than Earth is?
Okay, much longer, but still okay. It only takes 2 more years to pass the heliopause and 1 more to pass Voyager 2,
Yeah, and Voyager 2's been going for a while.
which travelled over 50 years to
Yeah,
get
50 years, and then they'll basically
the
get there in what?
heliopause and 1 more to pass Voyager
Yeah, just take like what, 4
2.
years, and it's been traveling for 50. So like you can imagine the sheer disappointment and sadness you'd feel if you spent your entire life on this voyage only to get lapped in like a year, 50 years later. It'd just be
Which travelled
heartbreaking.
over 50 years to get this far. Great. The next stop is the end of the Oort cloud, the true edge of the
5,000 to 100,000 AU. 5,000 times further away from Earth, from the sun than Earth is, and then 100,000. Like that's a massive gap. 45,000 AU.
solar system where open space begins. We reach it in 2,500 years. Oh. Oh no. Not only
Yeah.
did we travel for the amount of time it took to get from the founding of the Roman Republic
Yeah, you'd basically be traveling for all of human history. It just there's the Oort cloud, the edges of the Oort cloud. It's so hard to wrap your head around that. Yeah, even after 2,500 years of travel time, you'd still be, if you zoom out, you'd still be close to the Earth and the sun.
to the present day, there's nothing out here. This is the invisible barrier, the barrier of nothingness that might trap us in the solar system forever.
Yeah, because like going to another planet is fine. You can like reach it. Mars, doable. Venus, I don't think you'd want to go there, but you technically could if you really wanted to. But going to like someplace like this, where the only thing awaiting you is nothing, some clumps of dust and just nothing, there's not really much to gain. Like it's something you like stop through, but not really. I'm going there just to say I went there because there's nothing there.
Space tends to be like that. There is a place that's very far away, but with human ingenuity and billions of dollars, we can get there. Then you zoom out one more time, and all hope leaves your body. And
Yeah,
the
because it's big. You can zoom in just fine, but zooming out, it quickly becomes, yeah, we can't do that.
problem is that we've barely started zooming out. Why don't we just go faster?
Yeah, and the
Well,
thing about space is it's big, but there's a lot of nothing. There are things in there, but they tend to clump together. So if it's not clumped together near you, you're cooked. The time it takes to get there,
but
oof.
we've barely started zooming out. Why don't we just go faster? Well, we don't know of a non-magic way to
Technology.
travel faster than light,
Yeah.
teleport, or freeze people. So,
Cryo would be
of
crazy.
a non-magic way to travel faster than light,
You can't exceed FTL, yeah.
teleport, or
Teleportation, I think, yeah, good luck breaking down your basically atoms and then putting them back together somewhere else.
freeze people.
And then cryo is crazy because, ooh, I mean, you could freeze someone. You could definitely freeze someone. Thawing them and keeping them alive, though, yeah,
So, no warp drive
that's
for
the
now.
issue.
But things like a propulsion system that uses nuclear fusion or antimatter, powerful enough to
Yarp.
reach a substantial fraction of the speed of light, are in the realm of the physically possible. Ignoring the technical details and various problems that these
Yeah, you have to ignore them because trying to say, oh, yeah, we can put the money, the funding, the technology, all of that is a problem.
sources have will be very optimistic and make the reasonable assumption that we can get a spaceship to fly at around 20% the speed of light,
20%
which
the
is
speed of light.
extremely fast.
Yeah, no, that's fast because light is fast.
60,000 kilometers per second
60,000 kilometers per second. How fast is that? $37,282 miles per second.
216
I missed it.
million kilometers fast, 60,000 kilometers per
That's 1.5 times around the Earth in a second. That's so fast. Like the 4-minute one was crazy, but this one, 1.5 times in a single second. At some point, speed stops making, this much faster and then this much faster. It doesn't really seem to matter. But then when you go to space, that distinction matters. Because 4 minutes and then 1.5 times a second, that's several times. Wait, no, not even several times. Way, way, way faster.
second, 216
About an hour to the asteroid belt.
million kilometers per hour. Fast enough to reach the edge of the solar system in just 3.5 days.
Yeah, before how long did it take? Years?
That fast with a human crew, but our new spaceship covers the will reach after about a year, 11 to 10. Pretty good. Mars, but our new spaceship Pluto, which will reach after about a year.
So yeah, you'd be reaching Pluto in a year, and
Nation.com these energy sources are physically possible. Ignoring the technical details, and that we can get a spaceship 60,000 kilometers per the edge of the solar system in just 3.5 days.
yeah, so you went from 3 years to 3.5 days.
And the outer edge of the Oort cloud in 8 years.
That's way better.
Alpha Centauri,
That's way better.
the closest star system to our own, in 20 years.
You see, this is a much more human-friendly timescales. 2,500 years, insane. 20 years, crazy, extremely crazy. But you can do it. It's not like, it's not like you're spending your entire lifetime and your kids are spending their lifetimes and your grandkids are spending their lifetimes on this single mission. You get to do it and you can return in 40 years.
We can work with that.
Yeah.
There's only one small problem. We don't have internet. Wait, what? Just kidding.
Where is
But our
the-
sponsor,
oh,
Saley
there it was.
Nation, will go back. Well, there's only one small issue. Space hates you. The barrier of dust.
Right. When you're going that fast. Any collision at all is horrible. It's just a particle of dust. No. It will absolutely mess up your ship. Because the speed you're going, ooh.
Unfortunately, we'll run into a few obstacles on the way. Literally. Because while space is very empty, it's not actually
Yeah, no,
empty.
there's still stuff in there.
There are energetic particles, gas, dust, and things bigger than dust.
Yeah.
As a lot of unhappy people experience every day, if you're going really fast and smash into something, you have a huge problem.
Yeah.
And at 20% the speed of light, this is true even if the thing you're smashing into is just an atom.
Oh.
An individual
I didn't know it was that small. An atom can cause problems. But you're going to run into that. Like, yeah, there's not like a bunch of stuff, but I'm pretty sure there's atoms. Like, there's just no way you're gonna go light years and not hit anything.
iron atom that hits your spaceship at this speed has enough energy to carve a damage track tenths of a millimeter deep. Over time,
I
its
mean, yeah, initially it wouldn't cause much problems, but it will shred your ship eventually.
hull will be riddled with microscopic bullet holes, which is not great. Of course, our engineers knew this and created a shield for our
Oh,
ship. A sort of
okay.
protective sail that absorbs or at least slows down most molecules we smash into. And while this makes the journey
That's a
much
wider
safer,
surface
there
area,
are things
though.
floating around in space that are larger than atoms.
Yeah.
Running into a
Yeah, you have like, I mean, while I'm pretty sure that like be really rare to run into, you'd have things like rocks, comets, asteroids that's like got flung out of their own galaxies or solar systems. Well, no, it'd be solar systems. We're still in Milky Way. We're still in Milky Way.
single grain of dust at 20% the
Oops.
speed of light is like running into a grenade, causing a tiny detonation
Grenade. I see the wordplay there.
as the dust explosively evaporates is like running into a grenade.
So a particle of dust basically detonates like a grenade on impact with your shield.
causing a tiny detonation as the dust explosively evaporates, grinding away
So if you actually run into like a comet, you're basically nuking yourself.
our protective shield. But you can also hit something bigger than a grain
Yeah,
of dust, like a small rock the size of a golf ball. Hitting that at 20% the speed of light releases more than double the energy of the nuclear bomb.
I knew it. I knew it. I knew it. If a particle of dust was a hand grenade, a golf ball sized piece of rock detonates with the force of two nuclear bombs. There's no way. You'd need there's no way you can actually travel that fast out there then. You'd need some way to make sure your path is clear. Because no shield can really tank nuclear bombs indefinitely. The fact it could even tank one or two is crazy.
Bomb that was dropped over Hiroshima. We'll not even talk about anything larger.
Yeah, it doesn't make
Atoms,
sense.
dust, and pebbles are dangerous enough. We might have reached our natural speed limit here.
I mean,
Beside the
20%
fact
is
that
still
we don't
pretty
have a good
fast.
idea how we could possibly fly any faster, all of the damaging effects of hitting stuff floating around in the void get much worse fast.
Yeah, because even if you went at say 50%, even if you could, you're still constrained by the fact it gets all the more worse if you hit something. Like that particle of dust at 20% being a hand grenade, at 50% would probably be worse than like 10 nukes. Or worse. It's just
Having said all that, it's probably fair to assume that with enough shielding, our spaceship should be able to survive traveling through space at roughly 20% the speed of light, long enough
should.
to get to at least nearby stars
Yeah,
in
you're
a
not
reasonable
traveling
amount of time.
indefinitely.
Only one more issue to overcome. Almost everything in space that's close is super lame.
Fair. You have planets that rain diamonds. You have planets that look habitable. You have planet with like 3 suns. All of that is cool. I don't think any of that is nearby though. So you'd be journeying all of this, taking all this risk, and then when you get over there, it's the lamest stuff ever. It's boring. Like imagine.
The first proper target outside the solar system is the Alpha Centauri system,
Alpha Centauri is pretty cool though. 3 suns, well, 3 stars.
which is roughly 10,000 years with our original slow, more realistic
Yeah, 10,000 years. That's not gonna quite cut it. We might as well not start.
ship, but only 20 years with our super
Way more
fast
doable.
fictional ship. So let's cram a few unlucky humans into a tiny box for 20 years and send them on their way and assume they somehow make it without murdering each other.
They are unlucky. I mean, great team building exercise. You're together for 20 years. Either you grow to love that person or you hate them. You hate them a lot.
4 years after their arrival, their message reaches Earth. People around the globe gather together and hold their breath, eager to listen to it. We arrived. Alpha Centauri and its planets are very pretty up close. Unfortunately, they're all super deadly and uninhabitable. But we're doing extremely cool astrophysics and are learning a lot, which is pretty exciting. We're getting kind of tired of freeze-dried food and desperately need new shows to watch though. Not sure what we were thinking coming here.
Yeah, because even when you get over there, yeah, it's pretty. Beautiful. A wonder for the eyes. But what do you do now? You can't you can't land on the planet. You're confined to your spaceship. You're still eating the reserves you came with. What was the point? Besides, like science, exploration, but like actually doing something after you get there, ooh, that's not happening.
The thing about space is that almost all close destinations, if close means something different from what it usually means,
I mean, it is close relative to space. If you zoom out really far, it wouldn't even look like there's separation between us. We'd look like we're in the same spot.
are pretty lame.
Yeah.
Not from a scientific perspective, of course. It
I
would be
mean,
an
science would have a field day. They would have a field day, but anyone else? Not so much.
absolute dream to have the privilege to set foot on foreign planets and
Yeah.
marvel at the wonders of our universe.
I'm not saying it wouldn't be cool. It would. But that would like have to take into consideration going down on the planet. Staying in space looking at the planet though, ooh. That would be horrible.
But if 20% of the speed of light might be our speed limit, and we give humans a realistic travel time of say 40 years, we could reach things that are up to 8 light years away. None of the targets remotely within this range within a human lifetime may be worth traveling dozens of years in a tiny box through one of the deadliest environments imaginable.
No.
Our solar system is a bit unlucky in that regard. We're in a relatively empty pocket of the galaxy. This might change in a few million
Our spawn was cooked from the start.
years as we move through the galaxy, and there might be small, localized star-spanning civilizations. We discussed
We only have to survive. We only have to survive for how
through the
much?
galaxy, and there might be small. This might change in a few million years as
It's only a few billion years, guys. We can do it. We can survive 2 billion years so we can get cooler stuff. We just have to, survive. It's so far away. It's crazy. And the wait time is also crazy. But in terms of space, that's just normal. The thing about landing on another planet though, it's dangerous. On Earth, you've basically been exposed to like things like, you have your atmosphere, you have your biology, and you make it work. You get sick, you get better because your body has or your ancestor has been exposed to it, so your body has the immunities. But if you land on another planet and encounter like say what would be the equivalent of like a common cold, you have no immunity whatsoever. Zero. There's nothing your body can do because it's not your world. You've never been exposed to anything. Like if it's similar to Earth's, maybe you might have some like overlapping or similarities. But if not, ooh, taking one breath might just be the end of you because there's nothing you can do. Your biology isn't made for that planet.
we move through the galaxy, and there might be small, localized star-spanning civilizations. We discussed this in another video.
Aliens everywhere.
Let's say that we could go much further, to any of the stars within our stellar neighborhood, a sphere about 25 light years in diameter. 0.02% of the Milky Way, by the way. This
So low, bro. 0.02%. That's it. Not even 1%.
tiny bubble is currently inhabited by 34 stars and 6 brown dwarfs. Only 3
Decent.
stars in our neighborhood are similar to the Sun. But one of them is actually the Sun, and another one is Alpha
Well, that doesn't
Centauri
really
A.
count.
The other stars close to us are mostly red dwarfs with planets that vary from deadly to super deadly. There are a few planets
What
in
a
the habitable
selection.
zones of their stars where water can be liquid. But Mars is also in the habitable zone of the Sun, and it's really bad.
Yeah. Okay. Imagine this. You get on a spacecraft. The journey takes 55 years. You're told you're going to a planet that looks habitable. It's green, it's good. Everything points to this planet having life, theoretically. You get on this ship, 55 years pass, you arrive at the planet. And then it's dry, rock, and sand. Do you know what that would do to you? Do you know how depressing it would be to realize you spent the last 55 years of your life on nothing? Nothing at all? Because even if it looks habitable, it might not be. Look at Mars. Theoretically, it should have life. It's in the habitable zone. Earth has life, so why not Mars? But it just doesn't. Dry, hostile, and hot. It would just be soul crushing to get over there after 55 years and then realize there was nothing there to begin with. Like there's nothing you can do. You can't go back. You spent majority of your life spent on this. It would be enough to crush someone.
Even the planets that we think look most like Earth, like GJ
Yeah, it just might not be.
1061d, come with no guarantees.
No.
Imagine traveling your entire life
Yeah.
and then arriving at a Mars. What
That's what I was saying. That is what I was saying. Doing all of that, spending your entire life, and then you get a Mars for all your efforts. 55 years in near isolation, and then Mars at the end. You can't. Ugh, just imagining that
a
pisses me off.
brutal letdown that would be.
Yeah.
There are a few stars that would be interesting targets and may have actual habitable planets.
I mean, the best systems to go for then would probably be the systems with multiple habitable planets in their zones.
Planets with oceans and atmospheres that are breathable, which probably would mean that they have some form of microbial life, if not more.
That can absolutely and might pack you up. That said, what are the odds you'd be able to breathe on another planet? I don't know.
It would be extremely interesting and definitely worth it to check them out.
Yeah, it
But
would
they
be.
could be
It would be cool. You'd have a planet that's like all ocean. You'd have a planet that's like, mainly jungle. It'd be like biomes, really. I'm pretty sure that's not how that works, but it's cool to imagine. But getting there, it takes forever.
dozens, if not thousands, of light years away,
Yeah.
which means journeys of hundreds or thousands of years, even at a large fraction of the speed of light.
Yeah, it doesn't matter.
Of course, it is maybe feasible that a future humanity that is technologically way more advanced than us and very motivated could find solutions.
Yeah, that's the thing. You can't really say, yeah, it's not gonna happen. Back in 1080, they did not imagine fighter jets. They did not imagine tanks. They did not imagine nuclear bombs or spaceships or internet. All of that we see as normal. They couldn't have even imagined it. So it's not really like, oh yeah, it's impossible. It's just like really, really hard to do for us. But go like 300 years, maybe not.
Maybe they've solved biological aging and a travel
Ooh.
time of a few hundred years doesn't seem that
Solving aging would help with space exploration. But then you'd still need like, food, fuel. Aging just solves the lifespan issue, not the technical issues. Happy 317th birthday. At that point, you would need to spread into space though, because if no one really dies of old age, then you're just getting more and more people, and Earth can't sustain everyone indefinitely. But biological immortality would be a massive win,
bad to them. Maybe they could
so long as you had the space for it.
send AI spaceships with
Oh, I mean, I feel like there's some ways that could go like terribly wrong, and quite a few people that would oppose this. But in terms of, yeah, we want to go see out there, I mean, that's a valid way as much as
embryos or
any.
some version of that into space. They'd probably have way more advanced telescopes
Yeah.
to make sure they don't choose stars
They won't end up in the boat of 55 years of travel time and nothing to show for it.
systems that are deadly and empty.
Yeah.
But it's still hard to imagine without real science fiction technology how they could
That's the thing. Science fiction things like terraforming a planet, building a ring world, a Dyson sphere, faster than light travel, all of that, cool, granted, extremely cool. But They are, at the end of the day, science fiction until they're made. You can't absolutely say for certain it will never be made because you don't know. But right now, it's basically impossible.
Build and
Like, we can't even control Earth's climate, much less terraform another planet. So it's definitely a curve.
sustain a connected civilization.
Yeah.
Conclusion. The longer you think about deep space, the less it makes sense.
Yeah, no.
The distances are too vast. They
Yeah, you could go from Earth to any end of the observable universe, and it would take you literally forever. It's not technically infinite. There is like the barrier, or well, the edge is 65 billion light years away, I think. But to a human, even if you are biologically immortal, had infinite food and fuel, that journey, if you're moving even at the speed of light, will take billions of years. A star 10 million light years away, the light, which we cannot surpass the speed of, which is the speed of light, we can't pass that. It takes 10 million years to reach us. So it's really hard to wrap your head around. Light is fast, but space is big. So big that light just starts feeling slow, even no matter how fast it is.
There's a deadly speed limit, and even if we could solve these issues, almost all destinations even remotely reachable
Yeah, they
may not
suck.
be worth the
They
trip.
suck.
Space is the greatest challenge humanity will ever face.
I mean, we have the ocean on Earth. Some people are afraid of the ocean. I personally don't mind the ocean aside from the fact you can drown in it. I don't mind, like, it's deep, it's dark, it's cold. Yeah, sure. Oh wow, that sounded just like space, deep, dark, and cold. But it's still on Earth. For the most part, you can go in, you can swim. Space, you can't even step outside without a spacesuit. You're stuck in a spaceship. You need air to breathe. It's just not Earth. Like ocean, I can see why some people would be afraid of it. Space though, valid. Whether I would go, I would absolutely go. Just not on any like far voyage. But I would love to see like, space.
Right now, we're just not equipped or able to solve it.
No.
Rockets, computers, and even nuclear
It's just not
fusion
enough.
reactors are
No.
hopelessly underpowered. We need technology that's overwhelmingly transformative.
Yeah.
Something as wild to us as flying to the moon would have been to a hunter-gatherer.
Yeah, because you're using spares and sticks and tents. You could not fathom going to the moon. You looked at the moon and saw it as either some great deity, some wolf's left eye, some Greek god's home, or just like something like you know of but could never reach. It wasn't something like, oh yeah, definitely one day we'll be up there, we'll reach it. No. It was something that was just a part of the world as any of the stars in the background. Distant, not reachable. Couldn't even think about reaching it.
Will we ever get there? We genuinely don't know. But it is good to remind yourself of something. There are few things that make you look dumber than predicting the future of technology.
Yeah, because it can advance rapidly. It's supposedly supposed to advance a bit faster too with AI. Well, no, it definitely is. Not supposedly, it is. AI is real helpful in that regard. But yeah, saying, "Oh yeah, it's never gonna happen," and only for it to bite you, saying, and then it actually happens. Yeah, that would be embarrassing.
In 1903, the New York Times published an editorial, Flying Machines Which Do Not Fly, that confidently predicted it would take humans 1 to 10 million years to achieve powered flight.
You see, only a century, no, like a few decades after, no one has. There's no one in this world who hasn't heard of a plane. A plane is so commonplace. Flying around the world is so easy, so long as you mind swiping your card, that it's like there's no way, like, but 1 to 10 million years? We're only a century and a few decades after this. So that's just how it goes. You can't really say, oh, yeah, it'll never happen, or tens of 20 million years until it actually happens, because you don't know. There might just be a breakthrough that allows it, you know?
69 days later, the first successful flight happened.
It wasn't even a century, it wasn't even a decade. 69 days later, they had to eat their words. I know that publisher was like, "Oh, damn. Can I get the distributed copies back?" Because all of that, a million years to for this to work. 69 days later, people are flying.
66 years later, humans landed on the moon.
Yeah,
So we really hope this video will seem as dumb as this article in
the way they're all laughing, kicking their feet at the video.
100 years.
I mean, it might. It might. You can't really say it can't happen until humanity's extinct. Then you can say for certain it won't happen because everyone's dead and no one can do it. But so long as people exist, things can happen that allow for it.
And there's another option entirely. Maybe our thinking about all of this is just completely wrong. Maybe
The Kardashev scale is crazy. The way ranking civilizations based on energy usage. Eh,
the future is not out there, but deep down.
barrel
But we'll
scale.
explore that in another video.
What's the barrel scale? Is it just like going inwards instead of outwards?
The latest limited edition pin is here, continuing the cosmic time collection.
Advertisement. I enjoyed the video, much like Kurt, because I fumbled the name every time. Yeah, I enjoyed the video. Kurzgesagt. They usually have great videos, but I hope they're wrong. Space is too cool for us to be stuck in our solar system with like nothing. And it's not even like we're in a good spot. Our spawn sucked. We have nothing next to us. Everything next to us sucks. We don't have any cool planets. We don't. I hope they're wrong. I enjoy space. I do. I can't say I understand it very well. But hearing about it, listening to it, it's cool. It's just like so mind-boggling something can be that big and have so much stuff in it. Yeah, I like space. That said, I think that's all for today. If you enjoy my reactions, like, comment, subscribe. Yeah. If you have any impressions, feel free to leave a comment. I don't think I'm confused about anything. So yeah, no, that should be it. I will see you all in the next one.